How do you factor using the GCF, or the greatest common factor? So the first question we need to ask ourselves is, what is factoring? So factoring is simply unmultiplying, or you can also think of it as undoing the distributive property. So for example, looking over here, 2 times x minus 3, if I told you to simplify that, you would tell me that it's 2 times x, which is 2x, and 2 times negative 3, which is negative 6. You would distribute that out and multiply it to get a polynomial. Well, now we're going to start with something like 3x minus 12, and I'm going to tell you to go the other way. Figure out what factors we multiplied together to get that product. So we would have something times something. Okay, so that's what we're going to be doing today. We're going to be going backward. We're going to undo our distributive property. So looking at number 1 here, 4x squared plus 6x. First things we need to think of is, what are the factors of 4? So if we prime factorize this, this would be 2 times 2 times x times x. Those would be the factors of 4x squared. Likewise, 6x would be 2 times 3 times x. So think back to our factor trees. If you were to prime factor this out like we did in radicals. So now we need to figure out what the greatest common factor they have is. So they both have a 2. They both have an x. So the greatest common factor here is 2x. So now we have to figure out what we multiplied 2x by to get 4x squared plus 6x. So to do this, let's think back. So what times 2x would give me 4x squared? Well, if 2 times 2 is 4, x times x is x squared. So this, if I multiply this, would give me 4x squared. Similarly, 2x times what gives me a positive 6x? Well, 2 times 3 gives me 6, and 2x times 3 would give me that x. So this right here, 2x times 2x plus 3, would be the factored form of the product that we were given. So this is our answer. Now, you'll notice right here, 2x and 3 don't have any common factors. That's how we know we're finished. Okay, if they had something still in common, let's say we forgot to take the x out. Let's say we just took out a 2, and we still had 2x squared plus 3x, they would still have something in common in x. So you have to make sure that these terms that are left inside the parentheses have only a 1 in common. If they have anything else in common, then you're not done. So let's look at number 2. So again, we'll factor this out. So 3 is prime, so 3 times x times x. 12, we've done this one a lot. So 2 times 2 times 3, because it's 4 times 3, and 4 is 2 times 2 times x. And then 24, 4 times 6, which is 2 times 2 and 2 times 3. So 2 times 2 times 2 times 3 would be the prime factorization of 24. Now, when we start looking for what they have in common, notice all they have is a little 3. Now, I'm sure you can tell this can get very cumbersome very quickly, having to write out all these factors. So you should be able to just look and say, okay, 3, 12, and 24. I can divide all of those evenly by 3. 3 is the biggest number that will go evenly into all 3 of them. So 3 is what's coming out. They don't have an x in common. Even though these guys have x's in common, this one doesn't. So they all 3 have to have a shared factor. So that means no x's are coming out, just the number 3. So 3 times what gives me 3x squared? Well, that would be 1x squared. 3 times x squared is 3x squared. 3 times what gives me 12x? Well, 3 times 4 is 12, and then if we throw an x in there, 3 times 4x is 12x. Alright, 3 times what gives me negative 24? Well, 3 times negative 8 gives me negative 24. So this is the factored form. We are finished, and again, you can tell for sure by looking what's in the parentheses. Notice x squared, 4x, and 8 have only a 1 in common. Even though these two have a shared 4, the x squared does not have a 4 that I can divide by. Therefore, this is complete. They have to, all the different terms have to have something that can be divided by the same thing. Okay? So let's try number 3. So number 3 is going to be 4x to the 5th minus 6x cubed plus 10x squared. So let's not write out all the factors this time. Let's see if we can just look at the numbers and figure out what's going to go into all of them evenly. So 4, 6, and 10. We all know that there's going to be a 1 that goes in there. So if they have nothing in common, we just put a 1. But 4, 6, and 10 are all even numbers, which means the number 2 goes into them evenly. Now, if I divide 4 by 2, that's 2. If I divide 6 by 2, that's 3. If I divide 10 by 2, that's 5. And as far as I know, 2, 3, and 5 have nothing that go into all of them. So that means that 2 is going to be our greatest common factor. It's the biggest number we can divide evenly into all 3 of those numbers. Now looking at my x's, I have 5 here, 3 here, and 2 here. So the most x's they have in common is 2. I can't say 5 because this one doesn't have 5 x's to give and this one doesn't have 5 x's to give. The most any of them have to give are 2 x's. So we're going to say x squared is the rest of our GCF. So 2x squared is our greatest common factor. So then we have our parentheses, and now we're going to go backwards. So what times 2x squared gives me 4x to the 5th? Well, that would be 2x cubed. 2 times 2 is 4. X squared times x cubed is x to the 5th. 2 times what gives me negative 6? Well, that would be negative 3. And then x squared times what gives me x cubed? That would be an x. Then finally, 2 goes into 5. That's 2 goes into 10 5 times. So 2 times 5 is 10. And notice I already have my x squared. So this right here would be completed. 2x squared times 5 is 10x squared. And then looking in here again, 2, 3, and 5, they have nothing else in common. So you're done. All right, number 4. Negative 14x minus 21y. Now, there are 2 terms. So right off the bat, you could probably say, okay, 14 and 21, they have a 7 in common. Both of those numbers are divisible by 7, and you'd be right. Now, there is one little thing that's different about this problem than the other 3 we've looked at. If you look, notice all of these start with a positive term. This one doesn't. So the big thing with factoring is we don't like the first term to be negative. So we always factor out a negative if the first term is negative when it's in standard form. Now this is in standard form because x comes before y. So that means we need to take out a negative when we do our greatest common factor. So if you said 7, you were right. Negative 7 is what we are going to factor out. So negative 7 is the GCF. So negative 7 times what gives me negative 14x? Well, that would be 2x. Negative 7 times 2 is negative 14. Tag on the x. Now here's where you have to be careful. Negative 7 times what gives me negative 21? This would be a positive 3y. Okay, so anytime you have a negative for your first term, your leading coefficient has a negative, you must factor it out. That's just one of the big rules. Let's write that down. Leading coefficient must be positive. So you're going to factor out the negative. Okay, so that's a big rule here. So let's look at the next one. So we're going to do negative 8x squared minus 12x plus 4. So I want you to try this one. Now notice it has a negative, so you have to factor that out. I want you to try to factor this, and when you're ready, turn the video back on to check your answer. All right, if you're ready to check your answer, hopefully you realize that your greatest common factor is negative 4. You have to factor out the negative, and then 8, 12, and 4 can all be divided evenly by the number 4. So when you go backwards, negative 4 times 2x squared gives you that negative 8x squared. Negative 4 times 3x gives you negative 12x. And negative 4 times negative 1 gives you positive 4. Be very careful here. Some people think that's 0. It's not. Remember, you're multiplying. Negative 4 times negative 1 is what gives you the 4. Because there's 3 terms here, there should be 3 terms left over in your parentheses. Okay, you don't magically lose a term. And then notice 2x squared, 3x, and negative 1 have nothing in common other than 1. All right, number 6. Let's see. Negative 12 x squared y cubed plus 5xy squared. Now this has got a little more going on, but I think you can do it. So I want you to try it, and then if you get stuck, turn the video back on and I'll go through it with you. Alright, so the greatest common factor on here would be a negative 1 for the 12 and the 5, okay, because nothing can divide evenly with negative 12 and 5. So it would be a negative or a negative 1. If you wanted to put the 1 there, it'd be fine. And then they have 1 x in common, and they have 2 y's in common. So what would be left over is 12xy minus 5. Okay, so again, that's an understood negative 1. If you write the 1, it's okay. You can put it there. It's not a big deal. Most of the time we don't, though. It's understood. Just don't forget that you have to change this to a negative 5. All right, number 7. So let's throw in one that has fractions. We love fractions. 2/3 y to the 4th plus 1/3 y cubed minus 4/3 y squared. Now you might say, well, why don't, most of you know you could eliminate fractions by multiplying by the least common denominator. Well, the problem here is this is not an equation. If this was an equation, you could absolutely multiply everything by 3 and get rid of it. But we can't do that because if we multiply everything by 3 here, it's going to change the value of the expression. We can only do that if it has equals something where we can keep it balanced on both sides. So instead, we're going to get rid of that fraction by saying it's a common factor, factoring it out. So 2/3, 1/3, and 4/3 all have a third in common. So we're going to factor out a 1/3 to remove the fractions here. Then we're going to look at our y's. So looking here, y to the 4th, y cubed, and y squared, they all have a y squared in common. They have 2 y's that I can take out. So when I rewrite this, what times 1/3 gives me 2/3? Well, 1/3 times 2 gives me 2/3. Y squared times y squared gives me y to the 4th. All right, 1/3 times what gives me 1/3? Well, 1/3 times 1, okay, I'm not going to write the 1, it's understood. And then y squared times what? Y cubed, well, y, so 1y. 1/3 times y, or 1/3 y squared times 1y is going to give me 1/3 y cubed. If you write the 1, it's not a big deal again, you can do that. And then 1/3 times, well, negative 4 would give me negative 4/3. And then I don't need any y squareds. And then when I look inside here, now that there's no fractions to mess with, 2, 1, and negative 4 have nothing in common. So this one is completed. And it looks a little prettier because the fractions kind of move to the front out of the way to be done at the end.